Hello everyone, welcome back. We are going to look at shapes of molecules in today's lecture. And the shapes of molecule theory that we're going to use is called VSEPR for short. And VSEPR stands for valence shell. So that's the V, and that's the S. And the EP is electron pair. And the R stands for repulsion. So VSEPR theory is valence shell electron pair repulsion theory. And the basic idea is that those electrons tend to form little pairs with each other, and they're negatively charged. And because they're negatively charged, other electron pairs will be kind of pushed away from each other. They will try and stay as far away as possible. So whenever they're around an atom, they're going to try and stay the heck away from each other wherever they can. Now, what counts as an electron pair? So what counts as an electron pair in this theory is any kind of lone pair. So anytime you've got a lone pair, or another name for it is a non-bonding pair, that counts as a pair of electrons. So that counts as a pair. What's the other thing that can count as a pair? Any kind of bond. And here's the tricky thing. Now, it can be a single bond, it can be a double bond, or it can be a maxed out triple bond. And all of these are going to count just as a single electron pair. Now, you might say, well, that's not right, is it? I thought a single bond has one pair, but a double bond has two, and a triple bond has three pairs of electrons. And you're exactly right. But in this model, we basically take each one of these and just treat them as if they are an electron pair. Now, more sophisticated models would say the double bond is kind of a fatter electron pair, and a triple bond is an even plumper electron pair. But in this theory, basically, we got two kinds of pairs, either lone or bonds. All right, let's take a look at some examples here. So let's look at something like CO2, which is carbon dioxide. And we can draw a Lewis structure for it. And again, at this point in the course, I'm just going to draw them out. It's going to look something like so. And what I'm going to do here is I'm going to pick on normally the central atom. So most of these molecules we'll look at will be kind of small. So we're going to look at this carbon here in the center. And we're going to count how many pairs are around it. Now, what we have on the left is a double bond, and remember, any kind of bond counts as a pair, whether it's single, double, or triple. We all treat it as just one thing. And on the right-hand side, you've got a double bond. So there's two things repelling here. There's one over here, and there's one over here. Now, you might say, well, what about those lone pairs here, right? We got four of them we haven't counted up. Well, we're just looking around the central atom. So when we just pay attention to that center atom, there is two things attached. There's a double bond, there's a double bond, and these aren't directly attached. They're kind of a couple of units away. So we just look at what's exactly around there. So here we have two repulsions, and the question is, what do two repulsions look like? And I'm going to go ahead and pull up a website and try and show you a really neat animation here. So let's go to a new slide. Hey everyone, so this is the PhET website. So if you just search for PHET, you should find this website. And this is Molecular Shapes Basics. So what I've got here are three atoms on the screen, and essentially I've got two repulsions here. So I've got a bond on the left and a bond on the right. And notice as I move these around with my finger, they kind of wobble around, but eventually they kind of stay from each other, as far away from each other as possible. And I can click on this thing on the right to show the bond angles, and notice the angle's 180 degrees. So I can kind of sneak up on them, but notice that as I do that, everything springs back. If I try and sneak up in the other direction, right, it comes back to normal. So I've got a shape here, and I can click in the lower left-hand corner. It tells me the shape is linear, and it's called linear because all those atoms are in a straight line, and if I line them up, you can see they kind of line up perfectly, just like a pencil would be. So if we try and draw a carbon dioxide molecule, I can just kind of draw it over top like so. The Lewis structure looks something like this. And okay, so that is Lewis. And if we were trying to give it a three-dimensional look, right, we'd essentially draw it the way it appears on the screen. So we just draw the atoms in that sort of linear 180-degree mode. We'd probably go ahead and write, I don't know if yellow is the best color here, but anyway, we can write the 180-degree angle like so. And on an exam, right, I would expect you to be able to write the geometry name. So linear right next to it would be how you would show the geometry of CO2.